Hi, I'm Lasse Rindom, and I appreciate you listening in to this episode of The Only Constant. Sharing is caring, and it means a lot. If this episode sparks a thought with you, pass it on. You are listening to The Only Constant, a podcast where we go beyond the usual discussions in technology and business and aim to explore more than explain. Join me for engaging discussions with a diverse range of global thought leaders as we seek to uncover new perspectives and insights in a free-flowing conversation. My guest today is Robert Fuchs, and I am your host, Lasse Rindom. So, this is an episode I've been really looking forward to recording, and today I have Robert Fuchs with me. Robert is, I've called him a little hidden gem I sort of stumbled upon on LinkedIn, because Robert has been working for decades with building human-in-the-loop systems, but not necessarily in the typical business technology space like I work in, or the typical AI discussion would focus on, but for cars. So, welcome, Robert. I'm super excited to hear what you have to say.
Thank you very much. Good morning, and very glad to be here today.
So, Robert, what is human in the loop, and why does it matter so much when you're automating?
Well, technically speaking, human in the loop in automation is a hybrid approach where automation and human are integrated into a single workflow. But you can turn the definition the other way around by saying that until the complete autonomy is realized, the human will be always in the loop.
Hmm. Yeah, exactly. So, what does that mean? Will we ever get to that complete autonomy, or what do you think, or how is your experience in that?
Well, at least for the automotive industry, we didn't reach autonomy. This is again a matter of definition. What is autonomy? How far we have to go then that the human doesn't need to be involved anymore. Um, but let's start from the beginning. Automation is a progressive process. We start with a fully manual operation, and we start to increase progressively automation. And if you imagine a very complex system like an airplane or a nuclear power plant, you cannot reach autonomy so easily. And actually, today it's not. So you automate progressively different subsystems that will support the operator in terms of reducing the working load. Um, or in another way, you can augment the operator, so a single person can control a more complex system.
But adding that layer as well, the automation layer, is also increasing the complexity, isn't it? And as you said, a complex system would not reach autonomy as easily. So, is there a catch here?
Yes, absolutely. And um, you we try to um, relax the load on the operator by automating some parts of some sub aspect of the workflow. And here the human machine interaction or interface become critical, safety critical, to have a good
Mm.
communication, good interaction with the human. Now, yes, furthermore, it brings some ironies in the thing, yeah? Because the idea in with automation, the main motivation is to take off the human out of the loop, basically, because we always blame, the narrative is to blame the human for the error he's making. Humans are not
Mm.
perfect. That's what we hear often in the media. Now, this imperfect person has to design a perfect machine. And this is the first irony, you know. Yes. So, yes, perfect autonomy or perfect automation is very difficult to reach, and therefore we still need the human, and we need to understand how human can be still part of the process. And yes, and this is where this human-machine interaction, human-machine interface are so critical.
I think also you mentioned that in a prep chat we had that you the idea was, you could build steering, because that's what you're engineering, right,
Yes.
Robert?
Mhm.
And then you could be engineering on that for like a year or something like that, and then you gave it to a user, and he was like, "Nah, I can't feel the road," and then back to engineering again, right? Because it's all about having, this balance is not easy to obtain, right? That's the problem, isn't it?
Mhm. Yes. When you talk about automated driving, I think, yeah?
Mhm. No, I think
Yes.
actually the way you're just having the complexity of the system, where you have the steering of the car, where it
Mhm.
is also automated. There's a lot of things assisting the driver all
Yes.
the time, and
Yes,
that
yes.
is a super complex system, right? And then, but that means that you still need to make sure that the driver feels the road, has the right
Exactly.
feeling for the
Yes.
car, right?
Yeah.
And can you elaborate a little about on that process when you're building that?
Well, we developed some technology, for human in the loop in automated driving. Um, the the automated driving is there is a roadmap for the increasing the automation level from 0 to 5. Today, most of the car on the street are level 2, which means partial automation. Here, the driver is still in charge, so should have the hand on the steering wheel. But then, when you control your steering system, most of the control existing in the market, they blend the two control loop. One which is the robot-like operation of the vehicle that just follow a trajectory of the road, and the other one which is supporting the driver, assisting the driver while steering
Mm.
the car. Now, these two loops come into conflict in virtually all OEM steering control, which is kind of surprising. And then with this control, you are in a trade-off. So you can choose between tracking the road or enabling the driver to steer.
Mm.
And modulating between the two in real time is actually quite challenging. And this is why it takes so much time to have a good interaction in a car today. Even after nearly 20 years of development, most users, less than 50% of the users, don't like these ADAS, and therefore they don't activate the ADAS at all. So
Yeah,
some
the
OEM,
automated driver, right? Yeah.
yes, some OEMs, the one
What is an
that,
OEM?
sorry, the car makers,
Okay, yeah, sorry.
the car makers, um, the one that are a bit disruptive, like a Tesla or some in China, they they tend to show that the car can track very well any road, not only highway, but only also off highway. But then the steering wheel is becoming very hard. You cannot steer your car.
Mm.
Your steering wheel is locked. And if you want to steer, you have to apply very high torque on the steering wheel, and then you feel a shock, and then you are back in manual. There is no in between. Okay, it's
Mm.
or it's automated or manual.
Yeah,
But
yeah.
okay, but in terms of regulation, you are partially automated. You are still in charge. So you should still have your hand on the steering wheel. Other, what we call legacy OEM, the traditional OEMs, they tend to reduce the capability to track the road, but prioritizing the driver steering. So the driver can somehow steer.
But just to give a flavor here, how much has this, because in business we've also, had automated systems in applications and all that, and you've also had automations before, and that a car is not, it's not just, the wheel and then to the steering wheel to the wheels, and then you drive. Right, there is a lot of things going on in between the whole servo and all those things as well. So how much added complexity is it to add these AI capabilities, these autonomous capabilities to the steering in this respect compared to what you've been doing before? I think 20 years ago you were not working on. I don't know. Were you working on autonomous driving at that time?
No, no, not at all. But in terms of steering, we were working on getting a good steering feel, and of course, the technology evolved from a hydraulically assisted steering system to electric power steering system, um, which appears on the market in the end of the 80s, basically.
Mm,
And to answer to your question, how much work is required to implement automated driving? Of course, the engineers from the car maker had to implement all the sensor in the car, all the cameras, lidars, and all these sensor to be able to sense the road, to
mm,
get a view on the road, detect the lane, and then from this, with the AI machine or machine learning, whatever, to compute a trajectory where the car should go.
So first add all the
Okay.
senses and then to
Exactly.
compute the trajectory. Yeah.
So, and this was a major work, 20 years ago. That was not existing at all, and they had to focus on how to make this happening. In implementing sensor, making and generating a trajectory is such a complex work, and it's very
Mm,
impressive already what they can get to. But then, when they were able to do that, they finally the thing came to a point that then what would we do with the driver? The system is still not perfect. So we have to include the driver, and then we come back to human in the loop. How do we integrate the driver in the loop? And I don't know, like something like 10 years ago, we were talking about takeover maneuver or override. It's switching from manual to from automated to manual.
mm.
And this was giving a shock, and like I described before, what you can still see in some cars, which is very unpleasant. You can imagine if you are driving on the highway at over 100 kilometers per hour and you have a shock in your steering wheel. This is exactly what you don't want. And of course,
You
yeah.
hope I can imagine that I'm not using some of these brands that actually make me feel that, right?
So, and then we started to develop like a smooth transition between automated and manual to not to disturb or to disturb as less as possible
but
the driver.
that reduces the efficiency of both, doesn't it? Both the automation and the driver feeling, doesn't
Yes.
it?
Yes,
And isn't that the
exactly.
problem? So you're actually getting the worst of both worlds instead of the best.
Yes.
Or what is your opinion on that?
Yeah, exactly. So just to finish the story I was saying, then we started to make a smooth transition, and we realized to make that smooth transition that it's the in between that is interesting. Okay, is to mix
Mm,
the two, what we call shared control. So
mm.
the driver and the automation work together for driving. You don't deactivate the automation when the driver steer. And this is exactly what we do, and what we think is the best approach for human in the loop. It's to work together to make a team.
Okay, but when I then go, when I think AI and business AI, I have been saying for a long time that one of the biggest things we need to design for the future is not necessarily just the technology of how the autonomous dream, but the human in the loop design, right?
Exactly.
And I think that's also a post that we connected on when I wrote something like
Uh-huh.
that.
Hmm.
And obviously that would resonate a lot with you, but there would also be people now saying that, okay, so what Robert is saying is that if we do that, if we have to do that, then we're also getting a watered down AI. We're getting a light autonomous system, right? We're not getting
Hmm.
the best we
Hmm.
could from it. So maybe we should just cut out the steering feel. Maybe it doesn't matter. Steering feel mattered 20 years ago, but maybe it doesn't matter anymore. Do you think this is something that is going away? Is this a generational thing? It's because someone like you and me is still here who remembers how it was to, I don't know, drive an Alfa Romero on a mountain and way road, right, and feeling the road, and then now suddenly we're seeing, okay, it doesn't matter anymore. No one cares about steering feel. Like I spoke about in a couple of episodes back then. I just bought new speakers, and I realized my kids don't care. They don't care about sound quality. No kids today buy hi-fi, right? Will kids tomorrow buy steering feeling, Robert?
Yes, the steering feel will change. Obviously, you will not. You will maybe trade your steering feel of the road to a steering feel around the trajectory. Okay, you will be like driving on a valley, on the bottom of a valley, and then you will always feel the bottom. The car will always want to go back to the trajectory. So the
Yeah.
feeling will change, and I believe that in some years, maybe if we will be able to have partial automation from engine on to engine off, we will develop a new way of driving, and that will change the way we perceive driving, as you maybe try to suggest.
And
You
how?
try to suggest,
Just
yes.
elaborate a little bit about this to understand. What do you mean?
Well, you will always feel the trajectory in your hand. Today, you just feel what we call a reaction force on the steering wheel that just
Mm.
bring back the wheel to the center position. Okay.
Mm-hmm.
If you take off your hand, the steering will go back in the center when you are in manual drive. When you are in automated driving, when you steer away from the trajectory and you take off your hand, the car will always go back to the trajectory.
Yeah,
It's a bit
which is the average calculated route, right?
exactly, of course,
The
of
best.
course.
Yeah, exactly. So
Of
yeah,
course.
okay.
So the steering feel and the way you will interact with the car will change because of that. So,
Mm.
the steering feel will evolve. And another point in what you say, in AI, in the AI community, automated driving, I think it's a very critical aspect. I mean, this is safety critical.
Mm.
We cannot remove a steering feel at all. This is we are talking about safety. You have all, you know, a very large portion of the population driving. Things happen in less than 1 second.
Mm.
You cannot, safety is so critical in this kind of application. It will evolve with time, certainly. Yeah?
Mm.
Certainly, as automation will evolve and get more safer and safer, we will lose some aspect, definitely. But this will still take a lot of time, I think.
But I think also the aspect here is right that you said that they invented all these, or they built all these sensors into the cars, right? They built all this what we call multimodality, that the cars
Yes.
now has an ability to sense the world around it, right?
Mm-hmm.
And do things. And then they realized they had to sort of integrate that with your steering mechanisms, the way the human steers the car.
Mm-hmm.
And this also means that, because I think it's important to sometimes also emphasize that, and I try to say that, it's not just the steering wheel to the wheels. There is a complexity already in place. That, the way a car drove in the 90s was already complex. It was already complex to steer a car, right? So
Mm-hmm.
it's not like we're taking something simple and adding now the complexity to it. There is a need for a complexity to complexity, a translation, right? That's the maneuver, right? With adding this, isn't that right, Robert? Okay, because I'd love to just know a little bit about, how complex is it actually to steer a car? The whole setup here.
Um, the well, if I may change a little bit the focus of the question. I mean, you we all used to steering a car, okay? If
Hmm.
after a few years of experience, but that in some situation you get challenged. Okay, a couple of years ago, from my place, I went to the Pacific Ocean coast. I had a heavy lunch. I drive 2.5 hours to have a swim with my boy. We eat late and back at midnight with very heavy rain, thunderstorm, and everything. And I had a a partial automated car, and I could really rely on the functionality. It was really relieving me the
Mm.
load of having this car in control for still 2.5 hours over midnight.
Mm.
So it is very complicated, of course, but it gives like a psychological safety to the driver when you team up with the car. And I think this is where it is really interesting to have this kind of technology that is helping you.
Mm. Yeah. Obviously, and that is not that's not what I'm getting at. I think that point is right. But what I'm getting at is when we're building AI solutions right now for business as well, there is this it is treated as there is this sort of notion sometimes that this will be easy because the technology is great for the AI technology is great, but then it has to attach itself to a world that might look manual, right? But the manual is just another layer of what you could call legacy complexity. So I might be sitting here typing something from one system to another, but those two systems are also already automated to a high degree, and the complexity of all those assumptions sort of add up. So that's why I was trying to get at your engineering experience from
Okay.
before adding the autonomous driving to the car. That the complexity there is also there, right? Already, right?
Mm. It's already there, but of course, with the AI, we are trying to replace the human brain, basically. Huh? What
Mm,
makes driving possible? Huh? So we are reaching some very impressive results, of course. Um, but then the matter the point get down to what is safety? How do you define safety at the end?
mm.
And
And how
this
do you
is very
find that?
challenging. Well, yes, this is a very interesting discussion. One way is to compare the average mileage you can get before you get one accident. Huh? You can compare the automated car to the average human, and then you get a certain of the average human is like whatever mileage it is. But today, robotaxi, for example, they are not close to this line already. But then, if you go into some detail, the average mileage for human include all the impaired person,
Mm.
drunk drivers, drivers under drugs, effect of drugs, and everything. So if you take off these people, the bar is getting much higher, very very higher. Um, and it's becoming much more difficult to reach that level. Then on top of that, you can add the demographics. If the car is having accident only with elderly or only
Mm.
kids, even if you reach that level of accident per mileage, if the demographics or different race of people, it will not work.
So you're
It,
saying that what is
it,
the perfect human to compare it with? That's basically
yeah,
asking the question about the perfect human here, right?
perfect. No, it's an average. It's of course an average. But after your
Mm,
AI, have bias for
mm,
colors, for size, whatever. And then in terms of for the society to accept the technology, even if you have the same statistical level, you cannot accept that an automated driving car will hit more easily elderly than kids or uh, some race rather than other races. So that will be
no.
not acceptable. Okay, and then there is another interesting aspect is defensive driving. You could imagine an automated driving car that will drive very very safely in an almost unpredictable way for a human, and then causing accident on your back, not involving that actual automated driving cars. So that will
Mm,
not count as an automated driving car accident,
yeah.
but the cause is really that car. So safety is very, very difficult to assess in terms of numbers. And well, the latest I could find on the topic was that one of the abstract way of formulating that is that the car should drive in a responsible way, and the developer also has to work in a responsible way, which means to be transparent.
Mm.
Okay, you have to be transparent of what are the limits of the car you put on the street, because obviously you are testing still unsafe cars on the street, which is very challenging.
Yeah, exactly. But there's also this, this also means that if we had, if that they did, maybe AI would work best if every car was an AI-enabled car.
There is this discussion. Not very sure. Not very sure. Because of course, some human driver will avoid accident with an automated car that does silly things, I
Mm.
guess. But of course, I see where you want to go. Safety. One of the motivation for safety in automated driving cars is to say, when one of the car have an accident, you can fix the bug or fix the issue, and then spread that over all the fleet. Update the software and spread that over the fleet. Well, the opposite is when you have one bug, all the cars will have the bug. So
Yes.
it's a tricky line.
Yeah, and that is actually a very very smart thing to also say for automation with AI in general, right? That
Mm.
it is good because you can update the whole thing, right? But if you
Yes.
have one mistake, you will have that mistake spread out across
E-
all of the. If you have
Exactly.
50,000 customers working on your
Exactly.
ERP system, they will all get the same bug at the same
Mm.
time. Um, and I also think that there's something else here, right? That businesses, because I thought about, what if we all just had the same AI agents, right, in business? Would that make a difference? And, and that's where I get maybe to the difference, because for cars, it's very much, you're sharing the road. Everyone has the same, this is the trajectory we're driving on. This is what we're doing. But with businesses, there's multiple different aspects of what we're doing. There's a high differentiation. So just adding the same AI copilot to business is not the same as adding a copilot to something that has to drive on the streets. But I still think that it's also interesting that we are looking at the prospect of autonomous enterprises, right, in or autonomous businesses in 10, 20 years, or that is however long it will take. And you're saying that we've been working on autonomous driving for so long, where the medium is much more defined. It's the road, right? And we know where they are. Even we've mapped them out. We put them there. They're quite straightforward, and still it takes so much time to reach the autonomous level, or even reach just the medium level, the in the middle level, the human in the loop level, right?
I
If you
think
get where I'm getting with it.
yes. But yeah, for somehow it's very simple. If you just have to follow a road, it's very simple. If you just to follow what is static, the geography, the road, the
Mm.
lane, of course it's simple. When you add the traffic and the uncertainty, this is exactly where all is becoming much more challenging, and maybe much closer to business applications, as you mentioned them. um, yes, this is where it is very complicated, and all that in such a short reaction time that you have left. In business,
Mm.
we are not talking about less than 1 second reaction time, and uh, yes, that makes the thing really dynamic. And the consequences are very big. You would directly have an accident if something happen, and directly
But are we
social
actually are we
impact.
actually are we actually reducing our reaction time with when we're adding these automations to the workload, right? Because then suddenly we have to also take over.
You have to take over in the car, you mean?
Yeah. So are we reducing the reaction time? Because my reaction time would usually be I'm sitting there with my hand on the steering wheel, I'm driving myself, and now I'm reacting
Yeah,
to something happening. But when I'm in an automated system, I might be relying on the automation, and then suddenly be like, oh, I
exactly.
need to grab the steering wheel again, and
Exactly.
wake up. So are we actually reducing our reaction time? And is that maybe one of the biggest problems with when we're automating critical processes?
Yes, absolutely. This is where I mentioned before a first irony of automation, when I explained that the imperfect
Mm,
human will design a perfect machine. The other irony is that as the automation is getting more and more reliable, the the role of the driver will shift to a monitoring task. Okay, we will not steer anymore. We'll just
mm,
make sure that everything goes well. And we know from different experiences in aviation, air control, nuclear power plant control, that humans are very weak at monitoring things. You get distracted very easily. Then, furthermore, you lose situation awareness very easily. And then,
mm,
suddenly, when the unlikely event of a quite reliable automated car fails, in less than a second or within a second, you have to catch up. You have to switch to manual is extremely challenging. The more reliable the automation will be, the more skill will be required for the driver to recover the situation. And this is the second irony. And
Mm.
if you place that over time on top of it, we will have a skill degradation, which will obviously make the driver virtually in a situation where he will be not able to recover anything at all.
Yeah. Okay. So let me just rephrase that again. So what you said is that the more automated we get, the more skill is required when we need to take over when it fails. So we need
Exactly.
to have more skill
Exactly.
to react at the right time and with the right measure.
Exactly.
But as we automate more, we will have less skill to take over.
And obviously the
So
automation will have such a, you know, high quality driving. It will be very unlikely to have an accident, but when it happens, it will be so critical, so
mm.
unpredictable, if you want, that the skill required to the driver will be so high to recover the situation.
Yeah,
So
so it'll be like I think I read a book once spoke about the universe. I can't remember which one it was, but they said like most of the universe is just boring. It's just there. It's just nothing happens, and then suddenly it's terrifyingly, destructive. so 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 driving, automated driving might be the same, or I think he compared that also to the life of a soldier. Just boring drills, 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 and then death. So it's but
yeah,
but
well,
aggressive, improbable, terrifying death, right? At some, after all this boring stuff of carrying around bags with rocks or whatever, right? So. No, but the point is, I think that is a super. I wrote the other day that maybe this is the best AI we'll ever get because we are still able to criticize AI, right? And is that sort of the same thing, Robert?
mhm.
That now maybe our automated cars are the best now that they will ever be because we still know how to drive a car.
Yeah, yes, yes, it's very likely. I was thinking like, my father, my grandfather, they were not only driving, they were also repairing their car. We lose that part
Yeah,
already. And then we will
yeah,
lose
yeah. I have no
the
clue what I'm doing
driving
when I'm
maybe at
opening
some
it.
point. Exactly. You cannot, you open the trunk and you cannot do anything. Yeah.
I actually
You,
thought about that the other day, right? Like how come they understood all that, and I didn't. I don't. I read Steinbeck with the Grapes of Wrath, and they're constantly fixing their cars, right? They just and
yeah.
the son goes out fixing it. The dad he just and then he just adds something. They add some I don't know some tape here and there, and like how I would not know what to do. First thing I'll be like, what is this?
Yeah, well,
Just
today it's getting very challenging. Actually, if you don't have the tools, you can simply not do anything. Yeah.
So we have increased the complexity. Is that what you're saying, Robert? We increased it so much that it's almost impossible to understand and then fix for a human being.
Yeah. So we think that when you are automated driving, you should be very cautious, not to get to this level of challenging the human. Um, Maybe finding the best symbiosis between the machine and the man could be one way. I would
Mm.
say a cautious way. Uh, Again, I talk a lot about the technical complexity, but then you have after the complexity of the range of people driving. You will have elderly, young to elderly, unexperienced to elderly people. The solution is always to say everything will be automated, and you don't have this problem. But we don't get there easily yet. So you have to find solution in between, a cautious solution that will help all the categories of people, and make sure that the people also want to use that,
So is
because
it
we
step by
still
step thing? Is it just
yes
adding small
yes
things and then more and more? Or what is the
yes
approach that you're taking, Robert? Because I think what you just said, sounds like you would say, okay, let's not do this, right? More automated needs more skill, and we'll get less skill. So it sounds like, okay, let's not do this. But I don't think that's a possibility either, right? So you're tasked with building this, right?
what we are developing today is really the ability to steer together the car. Okay,
Hmm.
the driver can steer with the automation together, and you are always connected. Now, why do we do that? um, there is I think, two or three reasons. One is, or all is related to the fact that today partial automation, the ADAS, they are not contributing to traffic safety. Basically, we don't see their contribution to traffic safety after, I don't know, 15 years of cars on the road. One of the reasons is what we call usability. People don't like these ADAS, so they simply don't turn on, activate the partial automation of their car, which is a pity, honestly. So first is to try to find it. This is actually the most interesting aspect of the work, is how do you make the system that the people will be willing to activate it, you know?
Mm.
This is really, really, I think, the most important part. Then today, the ADAS, most of the cars can be activated only on highway. But highway is where you have the less likeliness of an accident.
Mm.
So it has to be operational off highway, which is more challenging, as I explained before, with the conventional control that you have to choose between steering or tracing or following the road. Sorry. What we develop today is enables to both track any road while enabling driver to steer over the
Mm.
automation. Okay, so this is the second point, and then you need affordability, because if automated driving is only for premium cars, we will never have an effect on traffic safety. Yeah? It has to be available to all cars.
Well, the benefits, yeah, we won't have the benefits of it either, right? So that would be the
Yeah,
problem.
exactly.
So what you're saying is that there's this. It's not for every road. It is not for all people today, and it may be too expensive also to get a hold of. That means that people are not using it. If people are not using it, we don't get the benefits, right? But at the same time, that's getting the benefits will also mean that they lose some of this connection with the car that is also so valuable, right? So this whole how are you approaching this whole the actual what is sort of the golden line for human in the loop steering, Robert?
The golden line is really to reach this teaming effect. Okay, that you will make a team between you and the automation, that you will like it, that you will rely on it. Okay,
Mm.
when the human will be challenged, the automation can take over. Not take over completely, but I mean can cover the weakness of the human. And when the
Mm.
automation is being challenged, the driver can also compensate for that. And this goes to the discussion around driver engagement. Okay, how much engagement
Yeah.
does it mean that we need to have always the hand on the steering wheel? Maybe, at least for some times. Um, in the future, we hope that sometimes we can just let it go and catch it again. But of course, this will be limited maybe to highway. Um, Off highway, things happen so quickly. The sensor also cannot see much far, what we call the horizon, horizon, how far you can see in front, how far the car can see in front of it. If you're on a straight line, it's like 100 or 200 meters. If you have a curve, it's directly finished, So,
Yeah, but that's the
yeah.
same. It's the same with AI, right? If something happens that is that you can't see, how do you react? There's a lot of analogies in this, and I really
Yes.
I think there's tons of analogies in everything you're saying.
Mhm. Yeah, human tend to reduce speed to get time, of course.
Yeah, yes, exactly.
Exactly.
But also, but I think that what you just said as well was that we should not necessarily automate everything
Mhm.
initially. That should not be the initial goal. The initial goal should be to cover the weakness of each other. So
Yes.
I cover the weakness of the automation, and the automation covers the weakness of me.
I think if we can reach that point, it would be um, a nice achievement. And we are working on that. We are control engineers.
Mhm.
We developed this new control, which is named pair driver. And now we are more and more focusing on human factor aspect, psychological aspect, to understand how people, or how the brain work, how the people feels, how trust is being built with the
Yeah.
system. This is essential to reach that level of, to reach the real team. Uh, eh, yeah, to build
So
the team.
you're
Sorry.
so you're working you're an engineer, but you're working with human mind, the
Yeah,
human.
exactly. It's
So,
automotive, like all transportation system, is you are not controlling a machine that is just in front of you. You are in the machine.
yeah, exactly. Yeah, yeah,
You're
you're
on
in the
board.
machine.
This is really different from basic robotics. When you see a robot working, doing some work next to you, no, you are in the machine.
Yeah, but that's actually, I think that's been. By the way, do you have psychologists hired as well to help you think
Yes,
about this, or you do?
yes,
Okay,
yes.
that's so cool. I like
Yeah,
that.
yeah.
But
Very important.
well, yeah, but so what do? They look at how the humans are responding to these changes,
Absolutely,
or
absolutely. Yeah, we have simulators, and we measure we measure the eyesight, the different the uh, heartbeat rate and things like that, to understand, try to measure qualitatively what's happening in how the human react in different situations.
if only we could do that when we build an AI automation for, I don't know, an invoice process, that we put heart rate monitors. Are you stressed now? Are you stressed with what the system is doing? That
Depends on how
would.
many zeros you put there.
Yeah, exactly. Let's just check all of our employees how stressed they are with this automation. But that also means, I've said that when we automate, we put the system at the center, right? We put ourselves in the machine, as you said as well.
Mhm,
Whereas
mhm,
previously, maybe we were we were at the center, and then we took the machines as some kind of functional thing we added on to our work, right? We
mhm,
could click this on and off, and but now it's sort of like, we are in the machine, or the machine is running it, and um, and how what does this do to the task that we as humans are tasked with when we are no longer at the center, but maybe more on the periphery, right?
mhm. Yeah, I'd like just to go back to the human in the loop definition, because I checked on Wikipedia how
Mm?
is it defined, and they defined it for machine learning as, um, in the sense when the human is aiding the computer to take the right decision when building a model.
Mm.
So the assumption is that the model will be perfect if the human is helping for the training
Yeah.
and the testing. But, well, with automated driving, it's not enough, obviously.
No.
And then you still need, human in the loop is an abstract notion. Huh? It never explains you how to implement it. So you can have a human in the loop to generate your AI algorithm. Human will help, but as you can see, for automated driving, you still need the human in the loop to steer together.
Mm.
And after, if you even go further with responsibility and accountability, if you have an accident, the human will be always in the loop, even after, to take responsibility.
Yeah, and I want to discuss that, because you mentioned the human crumple zone, right? So,
Yeah.
first off, what is a crumple zone, and what is the human crumple zone?
Well, it's the moral crumple zone, but the crumple zone in a car is the front and the rear part of the car that deforms easily to absorb the energy during a crash. Okay, it's the car is designed such a way to protect the cabin, and therefore the front and the rear of the car deformed to absorb the crash. Now, when you do automation, in automation, we have been able to distribute, the control, partly to the automation, partly to the user, but we still haven't been able to distribute that in terms of responsibility.
Mm.
So it means that when you have an accident, a crash, the the blame, the responsibility is always going to the human, to the operator. regardless if the operator could have saved recovered the crash, or just before the crash. So, and often there are many different examples, airplane crashes because for example, in the Airbus, the fly-by-wire doesn't give you a good haptic feedback, to say an example which is close to steering, and the co-pilot and co-pilot were panicking, not understanding what each other were doing with the joystick.
Mm.
And then the crash happened, a few hundred dead, unfortunately, and the pilots are being blamed.
Mm.
This is the moral crumple zone. If you don't design a system well, you put the user in a risk to become a moral crumple zone.
Mm.
Okay, so in terms of accountability, the solution would be that, of course, today we cannot blame a machine. Okay, to take responsibility, we need to blame another human. Okay, when you have
But
dead, you blame another people to take responsibility. Okay, now one of the solution would be to blame the operator or the developer.
yeah.
And this is really challenging, obviously. Yeah.
And then you need to also, unfold the complexity of their relationship to
Yeah.
figure out who was to blame. And and then
Yeah, of
we're
course,
in,
to investigate and to, yeah, of
yeah,
course.
and very very much investigate, and then becomes,
Mm.
like, I don't know if you watch football, like video assisted referees, right? It's like, who was it was it the human referee, or was it the other referee, or was it, was the player actually doing it? This whole, who is to blame, but also, uh, I think it is. I think what you just said was like, it's like and it's super interesting, with the moral crumple zone.
It is really interesting because everything, when you have such an accident, it works in the very short term. Okay, you have an
Mm.
accident, and then you have the investigation. Let's say for an airplane, you find the black box, and you have an investigation, and then you have the media directly covering the story and blaming usually the operator or the worker that was the closest to the situation.
Yeah,
So
exactly.
it's really a problem that goes directly to the society, and it's quite heavy. Yeah? We have to
But
be
this is
very,
what
very
I
careful.
spoke. But I spoke to Søren about this, and this was my thought, right? That on the podcast as well, Søren Friis Alexanderson, who is building agents for ERP systems, and he in Business Central and Microsoft, and I asked him actually, so when you're doing this, you're actually making service a software, right? And that means that when
Hmm.
your agents are taking over a process, it is actually an outsourcing activity. I'm outsourcing to the application. My responsibility, and that must mean that you have responsibility. And obviously he's from the development team, so he dodged that question. But that is the discussion we need to have, and that is the discussion just sort of opening up a little bit here, right? Isn't it, Robert?
Yeah,
That we
absolutely.
need to look at, is the car manufacturer then responsible for the crash? Or I don't know if you want to say that here on record,
Yes,
right?
that's where you have the problem. In the automotive industry, when you get above level 2, you get level 3, which is conditional automation, and level 4, which is highly automated, where you can take off your hand from the steering wheel and be even mind off. Um, Today, there are some companies like the robotaxi companies that are able to reach level 4, kind of level 4, with some, of course, limit, as I explained before, on safety. But they get really impressive results. Huh?
Mm.
Um, but the legacy, what we call legacy OEM, the traditional car makers, they are very cautious to go that far, huh, of course. Huh? They don't want to have cause accident. And even if they get to that level, they say, well, no, we sell it as a level 2, like
Mm.
partial automation. So it means the driver is in charge. The car has the brain, the capability work almost or very close to a level 4, but no, the driver take the responsibility. So we separate. Okay, we
But
have a
that is also
very
where we need to get. We need to have the car at that level so it can cover my weakness, right?
exactly. This is where the technology we develop could be very could use this in a very nice way by saying we are still together. The the car capability is really, or the automation capability is really increasing a lot, which will help to build trust. And then you are always together, and then you feel each other, and then you can complement
So
the drive.
this would mean for businesses that they should build up super autonomous AI capabilities, but not use them as such until they have been working uh, as co-pilots to humans for a long time.
Exactly. Until you can prove that it's really safe.
So you need to invest in having the perfect AI.
Well,
But
okay, yes, I see where you want to go, but
so
for
what you're saying
automotive,
is you've overinvested in AI, and you're not
yeah,
putting it in
I
the
see
cost.
where
That
you
is what
go.
you're saying, Robert, is it?
No. There is another good side of that story. If you get a car which can be, which has the capability near to level 4, but you sell it as level 2, you don't need the redundancy. You don't need to have double, sensors and double wires and double steering, all redundancy that makes the system fail safe.
Why?
If you are hands off and mind off, even
Yeah.
if the system fails, it has to be able to stop in a safe manner.
Okay. Okay.
Okay.
Yeah. Yeah.
If you are still responsible, you can take that off. All the redundancy cost, all the safety on cost, as we call it, can be reduced.
Yeah, but isn't that sort of like an old? Isn't that yeah, because everything's a software company, and will that not be disrupted? Right. We will have people building the software and putting it in the cars. Right. If you build this big AI that can do this, and you're just not attaching it, right? It seems. But
I know.
honestly, it also seems a little bit like a legacy OEM excuse, right? Saying, "Oh, we already did it, but we're just not giving it to you because we don't think you're ready for it." The world can't handle our automation, so we are. Yeah, I'm putting it a little bit, sarcastically here, right? But it's
Yeah, I know. Yeah, but the regulation and the law are a bit,
yeah.
late
Let's
on.
unpack that a little bit. What is there, in the regulation part of it? Because that's
The
where I know you also have some interpretations there as well.
Yeah, the regulation is following the technology basically. Yeah,
Mm,
the technology is driving, and then you have the regulation following behind, uh, and they adapt. The regulation is built around the technology that is existing.
yeah.
It's actually how can I say that? It it troubles me sometimes because it doesn't give an open mind. The mind, it's not open enough sometimes. It reduces the scope of what we should regulate. But unfortunately, this is one of the limits of what we can do with regulation. It's to base it on what we have, what is existing. Sometimes you want to um, you know uh, constrain a little bit what is existing,
Mm.
or sometimes you can open a little bit more to make sure innovation can progress fast. It's always a balance between the two, I guess.
Yeah. So what you're saying is that the regulation is always behind what we can actually do, and
Mhm.
that's why technology adoption is slower. Is that basically the core saying? But do you think that will just say, because I think Thor Dankert on the podcast said that if it's technically viable, it would become ethically feasible, or the other way around. I think technically feasible will become ethically viable. So if it's something that we can do, we will just say it's okay to do. But do you think that will also be the thing here with automation that way?
I think we are going back to the moral crumple zone here.
Yeah. Well, I
We have
think
to be
that's
very
also a
careful.
very, very, very interesting perspective, right?
Yeah. Well, Yes, and again, we should also always place that in the time scale. I mean, everything is so young.
Mm.
There is no maturity on most AI technology. We can address problems that we never addressed before with technology. Huh?
Yeah.
Even the business examples you mentioned, but but we don't have any depths, in terms of historical of an experience. You have to give time to all that as well. I think, which today's people engineer don't like actually.
No, the big human experience, right? Is all about. I just made a post today about that as well, right? That we can build perfect engineered stuff, and then the user can't operate it at all, and it doesn't make sense to a user, and then it doesn't matter, right? So then we need that experience, and that experience takes time because there needs a lot of testers and users who speak up and problems. And then you can change a small thing, and that's what, yeah, that's why I want to come back to that. What you said on in one, I think our first chat was, that you build this intricate steering mechanism, and you spend months and years on it, and then you give it to a test driver, and he's like, "Nah, it doesn't work for me." And then it's back again, go through all these complex parts again, and no, and that complexity is just increasing now, and we still have to just push it to the user, say, "What do you say to this automation?" Right? And they're like, "Nah, not really for me." Okay, okay, you go back again, and and that the iceberg below the surface, right, of work,
Mhm.
engineering work, right?
Yeah.
How is that increasing? Is that increasing? Is that just getting bigger and bigger all the time?
Oh, yes, 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 definitely, definitely. You can see that with automation. You can imagine the amount of work generated by driving automation. On the other side, you have the powertrain side, electric vehicle, hybrid, steel engine. Everything doubles in all
Yeah,
aspects of the car. So you can imagine the workload is just booming, I would say.
because it's all integrated solutions, right? And
Exactly.
integrated solutions are
Uh,
complex, and they keep getting
and
more and more. Should we just cut off some things, right? Should we just say, okay, we cut off the user, we cut off the gasoline engine, we cut off the hybrid. We Now it's just pure electric and pure automated, and then it's simple again.
could be, could be.
You don't have to have an opinion on that, but that could be.
Well, it will be simpler. You are correct.
Yeah,
It
but
will be simpler.
yeah, but it's the whole lean thing,
Um,
right? Cutting off some of the things that doesn't make value. We have too many products on
sure, sure.
our shelf, right? And maybe we should just lean our business.
But it will come naturally. This is economy, no?
Mm. Yeah.
Mm. Yeah, that's why.
No.
That's why. My opinion doesn't make sense. I mean, the economy will decide for us.
Mm. What will
But
win? Yeah, exactly. In the end.
what will
So,
not be sold will be obsolete
but
at some
but
point.
Robert, you've actually spent your entire career in building automations and human in the loop setups,
Mhm,
right?
mhm.
How are you sure you're making the world better for humans and not just more complex for humans to handle?
Well, today we believe that we have the best human-machine interaction system. First of all, is it the solution, the absolute solution? I'm not sure it's relative to what is existing today. Um, it is it is matching with the trend of what we understand today about what would be the best way to ensure driver engagement. We talked about human in the loop, but the opposite concept is we have to make sure that the driver is not getting out of the loop.
Mm.
This
Yeah.
is engagement, and this is why we use this technology to share the control of the steering. The driver is always steering, but the automation still on the background. It's always working. Um, we know that if you don't do that, like uh, like what Tesla is doing, the hard steering wheel,
Yeah.
the driver become discouraged from driving. I have my hand on the steering wheel, but I cannot do anything with it. So I take off my hand from the steering wheel. You should not,
Mm.
but this is what's happening. And then you are motivated to start multitasking, tapping text, and things like that. And this is why you have a so high rate of accident with those cars.
Yeah.
So sharing the control, at least today, is is the correct answer, solution, I would say. In the future too, even if automation is getting much better, let's say you go to level 4, you can be mind off. You say to your car, I want to go from A to B. And in between, you change your mind. You want to stop to go to the toilet. How do? You have to program your car. You would miss the toilet on the way.
Mm.
Things like that of course, 50, 100 years later, maybe there will be other things, of course. But the
Toilet in the
future,
car.
we
We'll
yeah,
just have a toilet in the car, Robert.
exactly.
You need to start building that. Why don't we build that?
Why not? But as we see the future today, I'm
But yeah,
being a
but you
bit
also, but
conservative,
you,
but
but
for
Robert, you're
reality.
also answering the question like a little bit like a passive consumer of something, or something's happening to me. The world is changing, and I just have to adapt to it. But you're also a lead engineer at a company that's actually building these automated systems as well, right? So are you making the world better? I'm going to ask you that question again.
Um, I hope that when our system will be um, largely deployed, that traffic safety will increase.
Mm.
As I said, um, human in the loop is this hybrid concept of the human and the automation working together on the same workflow on driving, for example. But when you do that, the human machine interaction is critical. Okay. This is what will
Mm.
define the safety of the system. It will help you reduce your working load. So I hope, when you drive a long distance with partial automation, and what I hear around my personal experience and what I hear around me, you are much less tired.
Mm.
So it's already beneficial. Huh?
Yeah.
Um, then if we could extend that to driving also off highway in any road, and you can, somehow rely on the system, reduce your load, and make the traffic safer. That's what we are aiming for. But it will
But
take years to prove, of course. Huh?
but there's also this whole right. So if I have a switch, right, and that's opposed to the way with co-driving. There's a co-driving, then there's a switch between automated and non-automated. The switch will make it easier to determine if we have a system crumple zone, right, or a moral human crumple zone, right? Because if you have this mix that you're building, you're also implicating the human in something that you previously on the episode today said that they will have less skill to do. So you are still automating it more, which means that you will require more skill from the human operator, but the human operator will become less skilled. Even though you keep them in the loop, you'll still be less skilled because they're more automated. But you're also involving them in the steering, and thus giving them a share of the responsibility in this moral crumple zone, right? Aren't you? So maybe the switch could be a better solution.
When the automation will be safe.
Yeah. But that's also
If we can prove
you,
safety, that's the
but yeah, but you get, but yeah, but you,
yeah,
yeah, but
I
you, yeah,
agree. I
but
agree with what you
you
say.
get my point, right? I'm just being
Yeah,
a little
absolutely.
critical here of it.
Yeah,
So
I
you're
know. I
building
know.
this, and you're saying all the right things, and then you say, but we want to involve the human, but then the human becomes also guilty, right?
Responsibility remains on the driver in this case. Yes.
Yeah, but what if we want to move in the future? In like 2 years, someone comes and say, "Well, we want to make the cars responsible," and then, but it'd be like, "No, but what Robert made meant that the human is still involved." So now it's on Robert's fault that we still have human crumple zones. Do you get what I'm getting at here,
Uh,
right?
well,
Blame Robert. We have these billboards. Blame Robert. It's Robert's fault.
no, no, no. Well, it's also when you see this level, something that always strikes me is when you see this level of automation. Okay, you go from you are in level 2, where
Mm,
the responsibility is the driver's responsible, and then you get to level, let's say 4, to say something a bit extreme. Suddenly it's the car responsibility.
mm,
The automation looks to be progressive, but the responsibility is just switching.
mm. Yeah, and what you're saying is that legally we don't
Yeah,
tend to.
and after how to deal with that, these are questions that not really specialist on, but this is a challenge. It's being discussed all the time, of course.
Yeah, and we don't adjust our legal frameworks until it's a fact, and
Exactly.
it won't become a fact
So
until we've
yes, yes.
adjusted our legal frameworks. So it's like a catch
So
22. It's
yeah,
moves
yeah,
around
yeah,
in
yeah.
circles, right? So
Exactly.
how we get this approved? We don't get it approved because it's not there, and it's not there
I
because it's
guess.
not approved.
And then you have the robotaxi starting to, run. Well, they're not starting; they are running. They are already causing some trouble and some casualty already.
But
So
also some
these
opportunities,
things.
right?
Yeah, of course, of course, of course, of course. I'm just talking about responsibility, how to deal that in the law.
Mm.
So we are creating a precedent, and everything is, we it's everything is new from a
Mm.
technical point to a society point. Uh,
So what you need for your human in the loop is to have legal in the loop.
as well, yes, that's why. That's what I told you. The human in the loop. If you see from a legal point of view, the human will be always in the loop.
Right now, at least.
Yeah, yeah,
And that's interesting, right? That's an
right.
interesting message also to say that we need to get that fixed and cleared off
Exactly,
quickly
exactly.
before we can move to these autonomous
Yeah.
levels that we want to, we are envisioning and we're talking about in conferences and meetings and hype talks.
Mhm.
Is that there's still this legal inhibition to get to that point, right?
Yes.
Um, can you I have this weird question also, I want you to give me a utopian and a dystopian future for a deep human in the loop expert, from a deep human in the loop expert like you. So what would be the worst situation? What would be the best situation?
Well, I think the worst is what I already mentioned before, like the motivation of autonomous driving, when the human is not needed anymore. The motivation behind autonomous driving is to take off the human error out of the loop.
Mm,
Um, and the system will improve theoretically by updating the software every time you find a mistake, or a bug. Every time you have an accident, you fix, and then you can deploy that to all the fleet. But
mm.
this is a beautiful story. Then you have the opposite. When you will have a bug, the whole car will have an accident, and I think this will be quite dystopian if it happened one day.
Did you see that? Did you see that movie? What was it? The movie where I can't remember the name of the movie right now. Where all the Teslas, they were taken over and they
Ah,
just drove
no,
into each
no,
other.
I
They were
heard
just
about it.
hacked and then
Yes.
they just drove smash,
Yes,
smash,
yes, yes.
smash, smash. Like, oh, okay, that's that. But it's sort of the same thing, right? The scaling of the
Yeah, yeah,
bug or the scaling of
exactly.
the solution, right? That
Yeah,
is why
I
you're
think
putting your utopian future is the scaling of the solution, but the
exactly,
dystopian is the scaling of the bug.
exactly, exactly.
That's really
Well,
neat.
yeah, yeah, yeah. Yeah, it's again an irony of all this technology stuff. Irony of
Mm,
automation, irony of deploying a software on a large scale and on safety critical system.
exactly.
Mhm.
Robert, this has been a splendid chat, and I have actually I have tons of I always write down while I'm talking with my guests, and I think I have one, two, three, four, five key key what do you call insights from this episode, right? The first thing is that this bug scaling we just talked about. Either you scale the bug or you scale the solution, right? How we're going to get around that. And also, yeah, the systems should cover the weakness of each other, not necessarily automate everything. And we need to make systems that people want to work with. Also, a very important
Mhm.
point. And that more automated means more skills are required, and but we'll have less skills at the same time. Um, I also wrote down. I think that was myself thinking that that are we sharing the same road? I think that's also an interesting thing. Do I with driving, or is it always the same road, or or is it really right? Is reality really predictable that way? And how does that sort of relate to business automation as well? And I have more notes as well. I think this has been a terrific conversation. Obviously, the whole human crumple zone discussion is perfect. It's a terrible one, right? And also it caught you,
Yes.
slightly uncomfortable on it a couple of times
Mhm.
because you're like, I don't have the perfect answer for it. But I love that you bring it up because it's something that we need to discuss.
Absolutely.
both in businesses but also on societal level. And I think it's also important for engineers to start discussing that as well, right? So
and I think
this is
it's sorry to interrupt. I think it's also our responsibility as we are designer, we are developer of complex system, and we have to understand this issue during the design, not after when it's on the market. This is, I think, one of our responsibility.
precisely, and that's why I'm so happy to have had this conversation with you today, to get all these experiences and sort of give it to my listeners to say this is some of the considerations and the concepts you need to think about when you're building autonomous systems and AI agents. It's not just engineering; it's more
Exactly.
than that.
Yeah.
So thank you for that, and thank you for this brilliant conversation. And Robert, I have one final question for you, and I hope you're ready for it.
Sure. Always.
So, Robert, what is the only constant?
The only constant, I think, for me would be our limitation, or the human limitation. I think this is how we feel about the world around us. Whatever technical achievement we will reach, I believe that we will always face a new limitation. But these are what challenges us, what motivate us to move forward. And consequently, as a researcher, my only constant would be exploration. Going behind my limits, crossing my borders, my frontiers. This is what helps me to make sense of what I am and what I'm doing and why, and I hope I can do that with sufficient responsibility.
That is a great constant. I love the limitations as a constant, and I love that you gave it a personal response with exploration as well, because that is how you're reacting to the constant you see in the world. So
Yes.
thank you so much for that, Robert, and thank you so much for being a guest on The Only Constant. It's been a real pleasure.
Thank you very much. The pleasure is shared. Thank you.
You've listened to The Only Constant, a podcast sponsored by Basico.